All right, 5.7. We're going to split up these notes into two parts. But for 5.7a, we are going to solve quadratic inequalities with one variable. Okay, so when looking at quadratics, again, we have parabolas. Okay, now we're going to start looking at inequalities. So we're going to see less than 0, greater than 0. Anytime we solved an equation, we always set it equal to 0. We're going to use that same idea with inequalities. Okay, so here, so we got a parabola here, and we're looking at when it's less than 0. Okay, so when you think about it, less than 0, and it's always y, right? So less than 0, we're going to look below the x-axis. Okay, so this part of our parabola right here is where it's less than 0. Okay, if we look on this one, again, below 0, less than 0. Okay, so that's where we're looking. Now, to write an answer to an inequality, it's always an inequality answer as well. So when we're looking here, okay, this is telling us our solutions are the shaded area. Okay, so it's between -1 and 3. Okay, so when we look at this, we could say that the values that would make this a solution is values that are x that are greater than -1 and x is less than 3. Okay, now that is one way to write it. The better way to write it, though, for an end statement is just like this. So -1 is less than x, which is less than 3. Okay, so right here, this is saying x is in between -1 and 3. Okay, like if we look at this part, that's saying x is greater than -1. This part here is saying x is less than 3. Okay, so we're just combining that end statement above into one inequality statement. Okay, I would prefer to see this statement here. Okay, so if it's in between two values, write the two values. Okay, it's between -1 and 3. Slap x in the middle, and then as long as you put the smaller number on the left and the larger number on the right, both inequality signs will be less than. Okay, now when we look at situations here, okay, where they're separated like that, okay, in this case, x has to be less than that -1, or x has to be greater than that 3. Okay, this one, that is the only way we can write that statement. Okay, it's this or this. Okay, nowhere in between. Okay, so x is less than -1, or x has to be greater than 3 in order to be less than 0. Okay, so on this one, when we're greater than 0, we're using that same idea. Okay, but now we're looking at greater than 0. Okay, so we're looking above the x-axis. So that's where we're looking, and we're going to write those inequality statements like we did above. Okay, so for that one on the left here, that's where it's separate. Okay, we have two zeros at -2 and 2. Okay, so at that -2, we're going to the left, so that's saying x is less than -2, or x is greater than 2. That is our answer for that one. Okay, and again, this one here, it's in between two values. Okay, it's between that -3 and 1. So again, x is greater than -3, and x has to be less than 1. And again, when we're writing the statement, I would prefer to see it as one statement, an equality statement. So a smaller number on the left, a larger number on the right, put x in the middle, and then less than signs in between both. Okay, so that is the idea we need moving forward. Now, here the graphs were given to you. Now I'm going to say solve the inequality algebraically. Okay, so what we're going to do is we're going to use one of those methods of solving that we've learned so far in chapter 5. So at this point, I've already tested you on the different types of solving. I don't care how you solve it, you just need to be able to solve it. So again, when I'm doing this, I'm always going to go to factoring first. Okay, so if I factor this, I see a positive and a negative. So both signs have to be negative. Has to be x. Ways to multiply, get 6, 1 and 6, 2 and 3. 2 and 3 work here. Okay, so that's our factored form. So if we solve that, again, we set both factors equal to 0. So x is equal to 2, x is equal to 3. Now, since it's an inequality, we have to go beyond that. Okay, if this was just an quadratic equation, those would be our solutions. But for an inequality, it is not. Okay, so what we need to do here, let's just do a rough sketch of what this would look like. Okay, we have x-intercepts of 2, 0, and 3, 0. Okay, and this is open up. Okay, so this is just a rough sketch of the graph. Now is the point where we go and look at the inequality. We're looking at when it's greater than or equal to 0. So again, greater than or equal to 0, we're above. So I'm looking at these two parts. And when they're separate like that, this is where we have that or statement. Okay, we have 2 here, we got 3 there. So x has to be less than 2, or x has to be greater than 3. Okay, so that is actually our answer there. And again, if it's an inequality, your answer will be written as an inequality as well. Okay, so let's go ahead, let's do one more. So we got 2x squared minus x is less than 3. Like I mentioned earlier, we still need to have that idea of like setting it equal to 0. Okay, so we need to get everything to one side. So when I do that, I'm going to get 2x squared minus x minus 3 is less than 0. Okay. So looking at that, again, I would go and try to factor it first. If that doesn't work, then I would probably move to quadratic formula. Okay, just a way to find your roots. Okay, so let's go ahead, let's try to factor this. It's going to be less than 0. Has to be at 2x and x. My signs have to be opposite. Okay, so I'm just going to go ahead and put plus minus there right away. And then the only way to multiply and get negative 3 is 1 and 3. So when I'm looking at this, 3 times 1, 1 times 2, that's going to somehow get me negative 1. Okay, but as of right now, I got negative 2x and 3x, and I need to get that negative x. So that tells me I need to flip-flop my signs. Now give me negative 3x, positive 2x. Okay, so we have it factored. Let's find those roots if it was an equation. Setting both factors equal to 0 and solving. So x equals 3 halves and x equals negative 1. Okay, so then again, we're going to just do a rough sketch. Okay, my roots tell me where it's going to cross the x-axis. So 3 halves, which is 1.5, and negative 1. So that's 2 points that would be on my graph. And this one will open up. Okay, and again, we don't need to worry about the vertex because this is just a rough sketch. All I'm looking for is which way it opens and where it crosses the x-axis. Okay, now for this one, we're looking at less than 0. So again, less than 0, we're looking below the x-axis. So that's where we're at. So we're between that negative 1 and 3 halves. So again, when we do this, smaller number on the left, larger number on the right, put x in the middle, less than signs. Again, this part right here is saying x is greater than negative 1. This part here is saying x is less than 3 halves. Okay. Alrighty. Let's see. Do we have another one there? I don't believe so. Nope, we do have one more. Okay, solve the inequality algebraically. So, again, I don't really care how you solve for your roots in these cases. So if you think you need to do quadratic formula every single time, do that. Okay, so let's go ahead. Let's just use a different method this time. Let's go use quadratic formula. We have it less than or equal to 0, so we're good there. So in order to find the roots, negative b, which would be 4, plus or minus the square root of b squared. So negative 4 squared, or 16, minus 4 times a times c, all over 2a. So from there, we got 4 plus or minus the square root of 16. It's going to be minus 2040 over negative 4, which is equal to 4 plus or minus the square root of negative 24 over negative 4. Okay, so this is a case where we came up with imaginary solutions. Okay, so in that case, we need to think about where this graph is at. Okay, I know that this is opening down, and since it's opening down, that means we're not going to be crossing the x-axis because of the imaginary solution. So this graph is somewhere down below the x-axis. Okay, again, we know that because we should have imaginary solutions, meaning it does not cross the x-axis, and we also know that it opens down, so it has to be somewhere below. Now, that's not the exact graph of it. Okay, I'm just indicating that we know that it doesn't cross the x-axis and it's opening down, so it's somewhere in quadrant 3 or 4. So now that we have that, we still need to look at the inequality. Okay, so then it's saying less than or equal to 0. So we're looking at below the x-axis. So in this case, that would include everything on the graph. Okay, so we're looking at the x values that make this true. In this case, it's going to be all, excuse me, all real numbers. Okay, no matter what I plug into x, we're going to get something that is less than 0. Okay, so that is our solution to that one. That one's a little more difficult. Okay, but the big thing when we are doing these, okay, find your roots. Okay, use one of those methods of solving: factoring, square rooting, completing the square, quadratic formula. Find those roots, do a quick rough sketch of it. Okay, look at which way it's opening, plot your roots, and then do that rough sketch. And then we're looking at the inequality then. Okay, if it's greater than 0, you're looking at above the x-axis. If it's less than 0, you look below the x-axis. Okay, so that is what we're going to do for today. So that was 5.7a. Okay, so in your homework, you have 5.7a homework. Okay, so go ahead, do that. If you have questions, make sure you are asking. Other than that, have a good day.